We have competing squares of opposition at work, don't we? So the modern square reflects the Boolean standpoint, and the traditional square reflects the Aristotelian standpoint. And these squares have some things in common. You'll see, for example, that both squares include the rule of contradiction, meaning that whether we're operating from the Boolean standpoint or the Aristotelian standpoint, corresponding A and O and corresponding E and I statements are always going to have opposite truth values from both standpoints. Similarly, the operations of conversion, perversion, and contraposition also function in the exact same way from both perspectives. And you can see that reflected here on these squares. But you can also see reflected here the implications of the Aristotelian assumption that we make arguments only about things that exist in reality. Okay, that assumption allows us to then create the rule of contrary, the rule of subcontrary, and the rule of subalternation. And now those rules are going to allow us to do a lot more with categorical, standard form categorical statements. Okay, so look, for example, what we could do with this statement from the modern perspective, from the Boolean standpoint. All A or B, and you're being told that's true. Are there inferences that you can make about other kinds of statements from the statement all A or B being true? And what I'm asking you there is there a way you could create an E statement or an I statement or an O statement that would have a known truth value from all A or B being true? And you're probably thinking to yourself, I know you are, you're thinking, well, sure, I could contrapose or avert all A or B and create two more statements that are true. I could contradict all A or B and come up with the statement some A or not B, and that would have to be false by contradiction. But that's about as far as I'm going to get, okay? Similarly, you could have a statement like some A or B and be told that's false, and you know that you could create a couple of more false statements, that you know there was a couple more statements with known truth values by converting or averting some A or B. And then you could also create the statement no A or B and know that's true by contradiction. But that's about as far as you're going to get. But now watch what happens when we operate from the traditional, the Aristotelian standpoint. If I'm told all A or B is true, I can, just like I did from the Boolean standpoint, I can contrapose or avert that and create two more statements with known truth values. But I can also now apply these other features of the traditional square. So for example, I know if all A or B is true by contradiction, just like with the modern square, some A or not B would have to be false. And I know by the rule of contrary, couldn't know this from the modern square, but I can from the traditional square. If all A or B is true, then by the rule of contrary, no A or B has to be false. And by the rule of subalternation, if all A or B is true, some A or B has to also be true. Okay, so we're going to be able to use the traditional square to evaluate arguments in ways that we weren't able to evaluate them from the the Boolean standpoint, from the modern square of opposition. And that's what we're going to start doing.